Everybody, it's Mr. Gustin. We're back in the physics classroom. I'm here today with Abby. Abby's going to help us with our rolling kinematics lab. Aren't you, Abby? Yeah. She's going to help us gather some data. So what we're looking at here is an object that's on a ramp, and I'm going to show you what we got going on here. Everyone say hi to Abby. Here's our ramp, and Abby's going to go ahead and roll this object down the ramp. We got to take some data, right, Abby? Mm-hmm. What data are we going to take? We're going to take some distance data. I'll get the radius of this thing later, but we're also going to take time data. So at home, I need you guys to take some time data for this. Abby, how many rolls can we make this thing go up the ramp? Three. So Abby's going to go ahead and roll this thing up the ramp 3 times. So we have the bottom of this disc right now is at the base, and she's going to roll it 3 full rotations so we know exactly what our theta is. Abby, go ahead and roll that thing up the ramp for us. We said it was 3 rotations? Yep. Did you get 3 full ones? Almost. There we go. All right, folks, so now you got to time this. Abby's going to drop it. I'm going to catch it. When she says go, 3, 2, 1, go, she's going to drop it. When it hits the bottom of the ramp, you stop your time. We're doing this 3 different times to get 3 trials with the data. Abby, you ready?
Yep. 3,
you count.
2, 1, go.
Oh, okay. Well, it fell off the ramp. Let's try that again. We started from where?
All right, like you.
It was right there. We're going to mark this ramp, too, so we know where to start it from. Okay, ready?
Okay.
It's going to be straight.
Yeah.
This is tricky.
3,
Go ahead.
2, 1, go. Ah.
Oh, goodness.
Hello.
Maybe 3 is too far.
Maybe. Okay. 3, 2, 1, go.
That's going to make it.
There we go.
Got it. Go ahead at home. That's 1 trial. Let's try it again.
3, 2, 1, go.
Oh! It's okay. If I was here, it would be going even worse. So
3, 2, 1, go. Oh my God.
maybe we flip it over. Let's flip it over.
Yeah.
Oh yeah, it's like curved. Where's the look? I see it. Oh, that was upside down. There we go. All right, ready?
All right.
Here's the edge. All right, this is gonna work.
3, 2, 1.
There we go. That's trial number 2, and then the last trial right here.
3, 2, 1.
Oh, we just had it flipped over wrong. Okay, perfect. That's 3 trials. Abby, will you go ahead and go get a meter stick out of that cabinet? Let's get the radius of this beam of that disc right there. So we have our time, the top one, top skinny. Time over here is what you calculate, and I want average time from all of you. I've got theta, that's 3 revolutions. Make sure you convert that over into radians. So 3 rotations times 2 pi radians per 1 rotation. Make your conversion so we get our answer in radians. Then we have time. You have your average time after the 3 trials. Abby, did you get the radius of that disc? We're going to get the radius of the disc. That will help us use any kind of conversions between linear and rotational kinematics. Our radius is... Let's get a diameter. What's the diameter?
Like 4.8.
So 14.8 is our diameter. So let's go with 7.4. 7.4 centimeters is our radius. That makes it 0.007, not 00, Gustin, 0.74 meters. That's my radius. So I've got number of rotations. I've got average time that you all calculated at home. I've got the radius. We dropped it from rest, right? Mm-hmm. So we also know that our initial omega was 0 radians per second. This is enough data that you should be able to go ahead and complete the rolling kinematics lab on in your packet, okay? So if you have questions, I guess you can send me an email or drop in the comments. Otherwise, until next time, we will see ya!